In this video, we're going to talk about the types of bonding, and there's three types of bondings which will be important for this upcoming test. So we'll go over each one briefly, and I have a few fun ways to help you remember, which will be at the end of this video, which will hopefully help you remember which types are which. So let's get started. So our first type of bonding is ionic bonding. Now ionic bonding is defined as the giving up or stealing of electrons. And so here we have depicted sodium and chloride. Now notice that sodium in its outermost shell only has 1 electron, and chloride has 7 in its outermost shell. If you remember, in order for an atom to be happy, it must have 8 electrons in its outermost shell. And so atoms do just about anything they can in order to get those 8 electrons in that outermost shell. So in this case, chloride is going to steal the blue electron, which is on that outermost shell of sodium. It's going to steal it so it can have 8 in its outermost shell. So here we go. Chloride has now stolen the electron from sodium. So now chloride is happy. He has 8 electrons in its outermost shell, and sodium essentially completely disregards the second or the third energy shell. Basically it doesn't even exist, and now it has 8 in its outermost shell. So now sodium and chloride are both happy, both having 8 electrons in each of their outermost shells. Now ionic bonding is created by opposites in charges. So sodium, because it has now lost 1 electron, has 1 more proton in its nucleus, 1 more positive charge. So it has a net +1 charge. And chloride, on the other hand, has now an extra electron, so it has a net charge of -1. And as we all know from kindergarten or elementary, opposites attract. So these opposite charges is what creates the bond. So the positive and negative charge of the sodium and chloride. Now sodium chloride is just basic table salt. So this is how table salt is formed. It's just chloride stealing electrons from sodium, creating opposites in charge, and those opposite charges is what attracts. So now let's move on to covalent bonding. Covalent bonding is all about sharing electrons. So in this case we have oxygen, which has 6 electrons in its outermost shell. So it essentially needs 2 more electrons in order to be happy. Now hydrogen, on the other hand, we have 2 hydrogen atoms here. Hydrogen only needs 1 because, as we know, that first energy shell only needs 2 electrons in order to be full. So both hydrogen atoms here only need 1 extra electron in order to be stable or happy. So what they do in covalent bonding is they actually share electrons. So in this case, this hydrogen will come and bond here, and the hydrogen will share these 2 electrons with this oxygen, and same with this second hydrogen. So now, because they're sharing electrons, the oxygen atom has 8 electrons in its outermost shell, and this hydrogen has 2 electrons in its outermost shell. So now all are happy, and this is what water is. Water is 2 hydrogens and 1 oxygen covalently bonded. So that's covalent bonding. It's all about sharing of electrons. Now hydrogen bonding is a little bit different. So we just talked about how water, in one water molecule, we have sharing of electrons between hydrogen and oxygen. But in this sharing, the sharing is actually a little bit unequal. So the oxygen, because it has more area, holds the electrons just a little bit longer than these hydrogen atoms do. So it has a slightly negative charge, and these hydrogens down here have a slightly positive charge. So hydrogen bonding is a bonding created from these opposite charges again, but just a little bit different, because it's the molecule that's charged, not the atom. So in this case, just like in ionic bonding, our opposites in charge will attract. So hydrogen bonding is the bonding between two molecules opposite of charge. Yeah, there's probably not a whole lot more you need to know about hydrogen bonding. It's a weak bond. We'll talk about it more with DNA. But this is why water, we can swim through water, because it's a fairly weak bond that can easily break and reform. And covalent bondings, which are between this hydrogen and this oxygen, is a fairly strong bond. So I have just a couple of fun ways to help you remember ionic and covalent bonding here on this site here. So let's look at that real quick. Okay. So covalent bonding, if you are co-workers, you share the work with each other. If you are in love, you share part of your heart with each other. So covalent bonding again is all about sharing. So co-workers share work. If you love someone, you share part of your heart. So here's a quick little silly video about falling in love.
I just wanna be okay, be okay, be okay. I just wanna be okay. I just wanna be okay, be okay, be okay. I just wanna be okay today. I just wanna feel.
So here's our two atoms. Both of them aren't happy because they don't have a full number of electrons. So here's an electron right here, part of the heart, and part of his electron. So now they're going to be sharing electrons, make a covalent bond, and which is a strong bond. Okay, so again, it's kind of a silly way to remember, but the crazier things you can come up with to remember terms, the better. So now let's move on to ionic bonding. So if you think only about yourself or I, you're more likely to steal something. And remember, ionic bonding is all about stealing of electrons. So here's some animals which know all about stealing. Alright, so that's enough of that video. So hopefully this helped. Bonding, as long as you understand the basics of it and the definitions of ionic and covalent bonding, in particular hydrogen bonding a little bit too, you should be good with any questions that you're asked about bonding. So hopefully this video has helped. If you have any questions, you can always email me. Have a great night.